Well, let's talk a little bit about Accent Digital. It's actually quite a bit to talk about here. So this is the new UHF digital wireless from Shure. This is our flagship wireless product now. It is very similar to Ulix Digital, and in some ways people have been asking for this and waiting for this for a while, because Ulix Digital hit the market 5 years ago now, and we have a product called Accent Analog that you may not heard of, that hit the market in 2011.
It's the highest end of highest end.
It's the highest end wireless that we've ever made in the industry, right? And people are like, why can't you take those two things and kind of smash them together? Well, that's pretty much what we've done here, with some exceptions, but that is kind of the concept here, and we'll get through that a little bit more as we get into it.
But price point per channel on analog Accent?
So just for price comparison, retail on a 2-channel receiver from Accent Analog was about $7,000, $7,300, I can't remember. Was 2-channel receiver retail. Retail price on a 4-channel, and that's retail price, MSRP, on a 4-channel Accent digital receiver is $6,000. So a 2-channel is $3,000. So less than half the cost on that.
Oh,
yeah. And then the transmitters are more like UHF-R. Well, I'll explain the transmitters in a second, because there's lots of different options on what we have there. You know, Accent Digital really replaces 2 of our products. UHF-R, which has been a standard of professional touring UHF analog wireless, has been discontinued, and it's replaced by the Accent Digital AD1 and AD2 handheld transmitters and body pack transmitters, and those are single frequency transmitters. They do not have any of the characteristics of Accent Analog, in that they can't automatically switch frequencies. They don't take advantage of the interference detection avoidance technology. They are just fixed frequency transmitters. So I'm kind of telling everyone it's pretty much it's digital UHF-R is what it is. And those are the AD transmitters. We also have the ADX transmitters, and those work with the remote ShowLink access points. They respond to interference detection and avoidance, and they can move frequencies in the air when interference is detected, which is what Accent Analog did. So this one product line replaces both UHF-R and Accent Analog. And these transmitters, as we'll talk through this in a little bit, the AD and ADX transmitters work with the receiver, and you can mix and match them at the same time on the same receiver. So you don't have to split out Accent Digital receivers. The receiver is the same for both types of transmitters, which is, as you see, is a really great advantage, because it allows you to kind of scale the system based on the needs and types of people that you're putting up there, you know. So your main microphones could take advantage of the interference detection avoidance technology, and you've got some other microphones in the system where the people aren't as critical maybe, and you just use the standard Accent Digital transmitters with them. So there's some pictures of them. They even form factor wise look different as well. The AD transmitters look like our ULX Digital and QLX Digital transmitters. The ADX transmitters, primarily the body packs, look more like the old Accent Analog. And we'll talk a little bit about that.
The ADX price point more in line with the
it's about 30% cheaper than the Accent Analog transmitters. And the AD transmitters are about the same price as the or they are the same mapped price actually as the UHF-R transmitters. So, price point of an Accent Digital system with AD transmitters, receiver, and everything is about what UHF-R was. And then Accent Digital, if you were completely Accent Digital, not a hybrid of the two. ADX. If you were completely ADX, not a hybrid of AD and ADX, you'd be about 30% cheaper still than Accent Analog. So.
ADX are the ones that work with ShowLink and work with.
Correct.
Full jump frequencies too. Yes.
That is correct. Yeah, they take advantage of the interference detection and avoidance and be assigned a new frequency.
And that's why broadcasters, if they were going to use, in mass critical scenarios, you'd have to have basically the security of no drops.
Right. That's the cannot fail.
Yeah,
Mission critical.
That's why they cost so much.
That's right. But cheaper than the analog. And one reason is the analog circuitry required to do that requires more pieces and parts. We're doing a lot of it with software now, so the actual physical components aren't as expensive to manufacture. Plus, it's kind of like I tell people all the time, it's like we went to the moon, with Axion Analog, and we can take all that technology we delivered or developed, just like the space program did, and then it just rolls out into all kinds of other products and applications. So that's the AD and ADX. Like I said, the receivers are the same for both transmitter types, and you can mix and match transmitters on the same receiver. You don't have to designate one for ADX and one for AD. You can mix and match any combination. We have a 2 and a 4 channel versions of the Axion digital receivers, and we'll look at that just a little bit more. These are the frequency bands that we're selling the transmitters in and the receivers. So for the most part, they're completely wide band. So that G57 band there will tune into all of the spectrum that is allowed legally in the UHF area. So all the way from 470 even up into that 614, 616 megahertz area. So one band, transmitters and receivers can tune anywhere in that. That's a huge advantage because it doesn't matter where you're at in the United States of America, you'll be able to find an empty TV channel. For example, in San Antonio, their empty TV channels are up in the 20s after this transition. Down here in Dallas-Fort Worth, it's 15 and 17, technically, with some co-channel operation and low-power TV stations. So, like with ULX Digital or UHFR or some of the competitor products, you might have to have a different set of receivers and transmitters to go from Dallas to an event in San Antonio. With Axion Digital, since it can tune that whole range, it doesn't matter. So for production and people that are traveling, this product is great because it can tune anywhere in the band. Now, we will have something called K54 that we can sell to licensed users that will fit into that duplex gap area that we talked about. Probably not what you would want to get for the most part, especially since we really don't know how usable that duplex gap will be, but it will be available, and it is a place to pick up a little bit more extra spectrum for somebody who's really crowded. But the primary band for the United States will be G57. There's also X55, which will only be available for Part 74 licensed users, and it fits in that top end of the spectrum we talked about where you have to register your frequencies, and you actually have to get with the Society of Broadcast Engineers in your area and get frequencies assigned from them, but you can't operate. So once again, for some people that really are just squeezed for frequencies, let's imagine Cowboys Stadium on game day or something, or the Super Bowl comes to town again, there's going to be some users that might use those other bands. But for the most part, G57 is going to be the one for everybody else, So talking about spectral efficiency, this applies to all of our digital UHF products, being QLX Digital, ULX Digital, and Axion Digital. We can do 17 wireless microphone systems from each of those models in an empty 6 megahertz TV channel in standard mode. 17. So probably the nearest competitor in the market can do 10 in a 6 megahertz TV channel. And ULX Digital and Axion Digital have something called high density mode, where the transmit power drops down to a lower level. And I'll show you what it kind of does on that slide there, but it allows us to do 47 systems in a 6 megahertz TV channel. So a lot of systems in a very, very tight space. And we'll talk through just kind of sort of how we do that in just a second.
So basically one TV channel slice,
Mm-hmm.
we can tune all of our pretty much everything.
That's right.
That we have.
Yeah.
By going to high density mode.
By going to high density mode.
And I guess you're going to talk about our range
Mm-hmm.
capacity. What's that cap?
Yeah. Well, if you look at this right here, this is from a oscilloscope measuring a wave both in standard mode and in high density mode. In standard mode, you've got about 200 kilohertz wide, and it's a little louder on the amplitude level. You can see that. And you can also see the way the bottom of the waveform kind of trails off a little wider. When we go into that high density mode, it does drop the transmit power, which actually, when you're operating in congested RF areas anyway, you only want to use you want to use the lowest transmit power you can, because that cuts down on bringing up the noise floor. The trade-off is going from 300, 350 feet between transmitter and antenna to go into maybe 150 feet from transmitter to antenna. Line of sight is, of course, the crucial thing always in that. We did a test at American Airlines Center during a Mavericks game right before Thanksgiving, and we took a couple of Axient digital body packs out there, and they have some of their UHFR and Axient analog, and we put all these packs and handhelds on this one guy, and we ran him around the arena before the game and during the game, and he had an Axient digital pack at 2 milliwatts, which is what it is in high density mode. He had one at 10 milliwatts, which is standard mode. He was holding one of the Axient digital handhelds at 35 milliwatts, which is our high power mode. He had the UHFR transmitter at its high power mode, and we ran a timeline on Wireless Workbench, and you could see everything. As long as he was in sight of the antenna, the 2 milliwatt mode, which is what it does in high density, was fine. We never lost it. It wasn't until he disappeared back behind the bleachers or started heading towards the tunnels and got out of the coverage area of the antenna that that signal dropped away. Even the standard mode, once he got into the tunnels there, dropped away. The crazy thing was that the Axient digital in 35 milliwatts mode, its high power mode, blasted. It never dropped out, and he went back up into a tunnel off, I don't know how far into it, and we never lost signal on that one. But as long as you have a good line of sight between the transmitting antenna and the receiving antenna, and you're within probably 150 feet, that 2 milliwatt mode, or 1 milliwatt for ULX digital and QLX digital, that goes into for high density mode, should be sufficient. So in a room like this, if all your transmitters were up there on that area and your antenna were back here and there was a good line of sight, you'd be fine in that high density or the lower power mode. And that would go true for just about every sanctuary or worship center I've been in. Once again, antenna placement, especially the receiving antenna placement, is critical. You can't put them below head where there's a lot of bodies in between. You need a good line of sight that gets over everyone's heads, on that.
They have some great videos on Shure's site showing them at the football field in downtown Chicago.
Soldier Field.
Soldier Field, thank you, Clayton. In high density mode, so at the 2 milliwatts, and he's, I think, 159 yards away with the pack behind him, big winter coat, in the middle of downtown Chicago with no drops.
Line of sight.
Yeah.
Antenna were right there on the field, and he had a great line of sight to him. So that's kind of what's happening there. The codec actually changes it a little bit when we go into 100 kilohertz mode. You'll see that the steeps of it, the side there, really gets a little bit more narrow and closed in. So the spacing in standard mode it's hard to see because of that red, but you need about 350 kilohertz ish in standard mode between our digital to make it really work. To kind of compare that to analog products, generally you want at least 400 kilohertz, even for a high-end analog product. Difference between an analog signal and a digital signal is an analog wireless signal will expand or compress depending on the dynamic signal coming into it. So the waveform actually moves with the dynamics of it. So if you get louder, it gets louder, and wider, softer it comes in. A digital signal doesn't do that at all. It's linear. It stays just like this because what happens is you have a higher dynamic input is it changes the bit value, right? That's all. It just changes to more ones and less zeros. So it can be very, very linear. So even in standard mode, we can space things pretty close together, 350 kilohertz. Well, when we go into high density mode, and what you're looking at there is still the not one. So we're now basically 125 kilohertz apart from center frequency to center frequency. And it kind of looks like those two signals are smashed together, doesn't it? But if you zoom in on the scope, you can see there's a very, very clear line between the edges of those two signals. So that's what's going on in high density mode. We're stacking things right next to each other like that. And this is a shot of 47 ULX digital transmitters in high density mode within a single 6 megahertz TV channel, all on and functioning together.
That's pretty crazy.
It's pretty crazy. So,
That's 47 anything.
ULX digital, Axient digital.
But it's body packs. handheld
That's right.
devices, and
That's right.
47.
Yeah.
Just transmission.
So, 98% of wireless users, with this product, we could fit all their channel needs into a single TV channel.
How does
I don't know that 98% is right, but most people,
how's intermodulation?
it doesn't it's not nearly as dramatic as analog signals, which can actually kind of demodulate each other. Digital signals just kind of collide, so they don't create as strong of intermods as an analog signal does. They do create them, but they're much diminished, greatly reduced compared to an analog signal. So.
And that's a proximity thing, right?
That's right.
So it seems like if you crammed 47 channels, and that means, let's just say a theater production. I don't know if anybody's ever had 47 on at one time.
That's 100 and just under 13 megahertz, right?
Yeah, if you took the rest of that out, there's actually 100 channels in basically 2 TV channels there, is what they did. And they laid them all out in a test at Shure in a room in rows, all about a foot apart.
Wow.
Yeah.
Are you kidding?
Not kidding.
I think I saw that video.
It's on the website. You can watch it. Yeah, that's what this screenshot's from. So. It's a mind melder, yeah. So that's the spectral efficiency. That's the 100 channels and 13 megahertz that Jeff was talking about from that test that they conducted, which you can watch a video of. And that was with ULX Digital. Axient Digital can do that as well. QLX Digital cannot do high-density mode, so that's a very significant difference. But for users who need, 20 channels, 30 channels, even after 2019, QLX Digital can provide that without having to go to high-density mode. So.
Is there any difference in audio quality versus high density mode versus standard mode?
There's not.
About the same?
Yeah. Yeah, it's still full bandwidth. So another difference between...
What's it code?
Oh, yeah.
Jump back there because that's a good question. In the digital mode, that's why you can do this, is there's an encode decode process that's going on, right?
Mm-hmm.
So basically from transmitter to receiver, there's a analog to, and it encodes it at the transmitter.
Correct.
Sends that via
Digitally through the air.
RF,
Correct.
yeah, but it decodes it once it gets over here. So it wouldn't, if I understand the theory right, it's there's no way it could affect the AF of that. So it's still
No, because you're still sending the
20
same
to
bits.
20 theoretically.
That's correct. Yeah. It's still 20 hertz, 20 kilohertz, because we're not throwing away bits
Yeah.
by going into high-density mode.
There's no truncation.
Right, we're not going to like a lossless or a non-lossless codec or something.
Right.
We're not doing some compression codec and squeezing in more territory by actually throwing away
I
bits.
think that's an extremely important
It's very important.
thing to understand about what's going on.
Mm-hmm.
Because you couldn't do that in the analog world.
Oh no, you'd have to somehow you'd lose something. You'd sacrifice something. Yeah.
All right, that's
Yeah.
good. Just wanted to ponder that for a second.
Yeah. So something else that is different in Axient Digital versus ULX Digital is the way that the antenna receivers work. So a lot of wireless systems, both analog and some digital, use something called predictive switching. So yes, they have 2 antenna inputs, but the receiver module is only looking at 1 antenna at a time, depending on what is determined to be a greater signal strength, and constantly switching back between the 2. SLX and ULX analog work this way. A lot of our competitors' analog devices work this way. ULX digital and QLX digital work this way. So you're putting in 2 antennas into them, but what's happening is it's looking at one or the other, and then in digital world it's doing error correction based on switching between those 2 and recreating the strings of 1 and 0. So this little video here kind of shows this going on here. So there's my 2 antenna, and it's showing some switching. It's kind of hard to see, but you see those bits over there on the right, and it's going to start feeding in the red ones and then the yellow ones, and it's mix matching those 2. And that's common, like I said, in a lot of mid-grade, low-grade wireless receivers. That's actually what's happening, is that they're switching to the stronger antenna signal.
And that's called
Predictive switching.
predictive switching.
Yeah, diversity. It is a type of diversity receiver, but it's called predictive switching. And it's worked very well. In fact, ULX Digital product was really designed for corporate presentation, house of worship speech. It wasn't really ever intended to be the highest end of wireless microphones. I'm not trying to degrade what it is, because it actually works quite well, and it was engineered great, and it's been very successful. But it really was never meant to go on tour with Aerosmith, for example, and it has. That was not the design. UHFR was that product, right? And so you can kind of see what it's doing with predictive switching. And so in a high noise environment, this is where this can become a problem. And I wish you could see a little bit better on here, but you're going to see this higher noise floor that's going to cause those antennas to switch back and forth a lot more. And then what you're seeing is you're catching little parts of the bits now, and it's trying to recreate those. There's going to be more gaps, and it's going to have to do more error correction to get that signal translated back into analog. And so in a higher RF noise floor, predictive switching can cause problems.
What's a dB range of a noise floor like that?
It's a really good question. I don't know. I have had very few instances where I've actually seen anything like this even kind of occur.
Okay.
I would say downtown Manhattan, outside.
Okay.
Downtown Dallas, Macy's Day float on the parade. I don't know.
But
Dallas
we're talking
Cowboys
about a little bit of the garbage
that's out there in the world.
Like LED walls. If you're doing a high impact type lighting show, things like
That's
that.
right. You could have a high RF noise floor,
Do you think that noise floor gets to that point?
potentially.
Okay.
Once again, Ulix Digital has been in use all over, big productions, and has worked quite well. But it is a predictive switching technology, and this just kind of shows you in a 4-channel Ulix Digital quad what's happening. Right? You do have 2 antennae coming in, but the receivers are switching and pointing to whichever antenna signal is strongest for that particular transmitter channel. So Accent Digital, UHFR, some of the high-end wireless from our competitors, uses actual true diversity, meaning that each receiver channel has 2 modules in it,
Okay.
and it's constantly receiving the information from both antenna. And this is actually an advantage because it's able to, get a better signal because it can synthesize that data without trying to jump and look at each one in a higher RF noise floor particularly. So if you look at this, you've got 2 antenna feeding in here, and they're summed together to come up with any drops or gaps that might occur in the signal there. So what you're seeing is the yellow and the red antenna, right? And we may lose a few bits here and there, but as they come through, error correction is able to feed the gaps in and feed out a steady string there, right? So even in a high RF noise floor, here's our higher noise floor. So now those antennae are dipping in that noise floor, and we do have some drops here. But because the other signal is constantly being analyzed too, it's going to synthesize those strings together. It's not got to do as much error correction, and you're going to come out with a more true representation of that signal. And that's the advantage of Accent Digital over the Ulix Digital product. Once again, don't want to diminish Ulix Digital. It works quite well. You own a lot of it and don't have any problems with it.
Yeah, right.
And so does a lot of other people in the world, most everyone that's bought it. But this is a step up in RF performance, and it's in the receiver module. This is the way UHFR worked as well, except with analog signals. It summed them 2 together. So we have a new concept based on this that the Accent Digital 4-channel receiver can do, and it's called quadversity mode. New word. Quadversity. Basically, in a 4-channel receiver, you have 4 receiver channels. Each one of those has 2 receiver modules, right? We rob the receiver module from channel 2 and apply them to channel 1, and we can rob the receiver modules from channel 4 and apply them to channel 3.
So
I mean, you go to a 2-channel receiver, but each channel has 4 receiver modules feeding into it. So it's taking all that information, and it can combine in the error correction and synthesize a better signal.
It's true diversity.
It's right, true diversity squared.
Yeah.
So what this allows you to do in a high RF environment especially is to use more antenna to try to pick up that signal. Another thing you could do with it is use it to extend your range as well. So, for example, this would probably have to do more with people that are doing production than someone with a fixed installation, because to extend your range in here, you could point a pair of antenna that way and one this way and then just combine them. and you probably get pretty good, signal still here. But in this sense, you could actually create kind of a second zone or even extend your coverage on a particular one. The other thing is in a high RF noise environment, downtown somewhere during a large event, the Super Bowl or whatever, 4 antenna is going to give you more of that data information coming in of the bits for it to kind of correct in there and just kind of make it that much more foolproof, honestly. So that's something called quadversity mode. When you do that, it does affect the entire receiver. And the dual channel receiver does not do quadversity mode, only the 4-channel.
And that's the Axient.
Digital only. Only the Axient digital 4-channel receiver can do that.
ADX only?
Nope, doesn't matter. You can do it AD or ADX. The transmitter doesn't matter. That's a receiver function.
Okay.
Because it actually does it basically robs the receiver modules from channel 2 and 4 and applies them to channel 1 and 3.
So if you're doing like a football game in the field, if you had antenna, quadversity, your ref or whoever's got the wireless mic in the middle, no matter where he goes, you've got an antenna spot somewhere.
Correct.
Or a parade.
Yeah.
Or you want to have powered antennas in here, but you're doing a performance where they start in the narthex and walk in. You can put omnidirectionals, or people want to put some UA 860s in the green room because this performance they have to start speaking off stage and come on. Or a performer likes to walk out in the crowd.
Yeah. Or the President of the United States comes to speak and his microphone cannot drop out. Yeah. So you just get that extra coverage on him, So anyway, I want to talk a little bit about the components now. This is going to look very familiar to you. That's the 4-channel Axient digital quad receiver. Looks a lot like a Ulix digital quad receiver, but there are some noticeable differences. First of all, we went back to the loop through on the power there. You can actually get a redundant DC power supply inserted on this. So you can have your AC power and run a redundant DC power, something that production people ask for, right? On a Ulix digital receiver, a quad, there's 2 network ports. We have 4 on here, right? Now, just like the Ulix digital quad, we can run that in what's called switched mode, which all 4 of those ports not only have Dante traffic on them, but they also have control traffic. Or we can run it in split redundant mode, just like a Ulix digital quad, except that you have 2 control ports and 2 Dante ports. You could do a whole redundant network, you can loop through to something else, but it also acts like a 4-port gigabit switch as well in switch mode. So just a couple extra ports there. We added...
gigabit isolated?
I believe it's a gigabit switch.
Okay.
Yeah.
On each port?
I believe so. Yeah. It doesn't really need... the Dante traffic that would come off of a single-channel receiver wouldn't be significant enough to really require a gigabit switch. Right. It's not till... I think Audinate says when you get to 32 channels of Dante, you really need to go to the gigabit switch, but they pretty much recommend to always use a managed gigabit switch anyway. But we added word clock. You can see that we added 1/4-inch outputs, which Ulix Digital doesn't have for people that are doing this with tar systems. Of course, we have XLR outputs, and we also added AES on here. So you can flip this into AES mode, and channel 3 and 4 become your AES stereo 1 and 2 and 3 and 4, and your XLR outputs don't do anything at all there. You'll notice there's a ground switch and a mic line switch on the output of every channel, so you can change those between them. Now, there's a real cool function in the hardware that we'll show you when we walk over there in a little while, but from the front panel of the receiver, I can tap into the switch settings and see what those switch settings are without having to crawl around back. You'll also notice that the back of the receiver is silver with a really nice black font on there. So they took a lot of time to design that so that you look in the back of a rack without a flashlight, you can actually pretty much read what that is. Hey, that's kind of important for everyone that's crawled around the back of a rack in a hurry.
Yeah, look at ours.
Yeah. So, they really took their time with this product. On the far right there, you do have 4 BNCs. In normal mode, you have your 2 antenna inputs, and then you can cascade to another receiver, just like with Ulix Digital. But if you're doing quadversity mode, that's where you plug in your other 2 antenna. And that's where you get your 4 antenna over there. So, let's see. We do have the talk switch output routing capabilities, so you can get an inline button that goes on the handheld transmitter. You pull off the capsule and put it in there. And what that will allow you to do is to either toggle or push to hold and switch the output of that channel from XLR to quarter inch or from Dante to quarter inch, whatever, so you can create a different feed that can go to people's in-ear monitors so that a performer or a pastor or whomever can talk to tech staff or talk to the band without it going across the full PA, right? So when that talk switch is engaged, it bypasses the output that's going to your console that you have going to the main PA system and switches to the other output, whether it be the quarter inch or XLR, however you set that up. It can go to a monitor feed or something like that, to a separate place in the chain. So that's something that's possible. And that works with AD or ADX transmitters, that little talk switch thing.
Is that on every transmitter?
You have to add it. You can do that on the handhelds.
Do you have one?
I don't yet. It's not shipping yet. And then they've talked about some sort of key fob that will work with the body packs, but with the ADX body packs, since there's the ability to transmit to them wirelessly, some sort of like thing, some sort of deal that will sit in somebody's pocket or hand where they can do the same thing with a body pack. That's just talked about, conjecture, haven't seen it, don't know anything more about it. That just is a better, I've already gone through all that really, but that's the back of it there. So we talked about the spectral efficiency, 17 channels in standard mode, 47 channels in high density mode, and a single TV channel. We talked about the quadversity function, and the other, obvious advantage RF-wise of these products is that the receiver's wideband. So that G57 frequency band will tune in everything allowable by the FCC. We've added some other things to this product that are kind of new to wireless. The first thing is something called channel quality metering. And this is a new metric that is available, and what it is a measurement of the error bit correction that's happening on that channel. So you know how much error bit correction is having to happen. So I'm just going to switch over real quick to Wireless Workbench, and I am going to pull up the monitor field for my channel that I'm on right now. And see those 5 dots right there? That's my channel quality measure, which means that currently this is getting all of its bit information over there. And you're really good until you get to about 2. You need to start questioning what's going on there. So, of course, I've got my RF signal. And look how low my RF signal is. And look how that changes when I change the orientation of my body. But look what the channel quality metric's doing. It just dropped to 4. Now it's at 5. I'm still pretty good. I'll start to do some stuff like this with the antenna. Maybe I can get it to, no, I can't get it to, there's 3 with my hand completely around. Yeah, and I've got, and just so you can see what I'm doing here, I mean, I'm completely covering that up right now. So that's a pretty cool feature, and you can actually see that in the timeline as well. I have to pull up my old man glasses here for a second so I can see the timeline. So I'm going to run my timeline here, and you can see in that top, if I can get this a little bit bigger. You can actually see all the metrics there. You can see audio and some other things like that.
Is that only on the Accent?
The quality channel metric is only on the Accent. By the way, all the Accent transmitters have a cool feature where you can enable an audio tone, either 400 hertz or 1 kilohertz from the transmitter. So, for example, I go down here in my audio menu, and I left my old man glasses over there. And I'm going to turn up a 400 kilohertz tone. And you can kind of see it popping up there on there, right? So I can unplug my microphone, right?
So you're getting it in there. But
Yeah.
Yeah, you hear it? Okay. This is a really nice feature because I can track the audio on the timeline. I could also pull this up in the PA. So if I'm by myself and I want to do a walk test, I can walk this whole arena instead of having to go check, 1, 2, check. I'll turn that down because it sounds like it's really loud up there. And it's got the equally annoying 400 hertz or 1 kilohertz tone. But anyway, if I'm by myself and I want to do a walk test, I don't have to hope that I just didn't say anything to the point that I get a dropout. So with this timeline metric, not only can I measure antenna signal strength, I can use that tone to watch my audio to look for dropouts. I've got that channel quality metric as well to see what's really happening with the error bit correction. So those are some really useful tools.
Yeah.
The other thing that it will do is, you can drop markers in your timeline. don't know if you've used that with Wireless Workbench before.
No.
When you're doing a walk test from the software, let's say you're doing the test and you're at the software and he gets up on the stage, you can drop a marker where he's at.
Okay.
And you can label that marker.
Oh, wow.
And you can do that with any of our networkable products. But with an Accent Digital transmitter, any of them, I can actually go and drop a marker from the transmitter. So I can be by myself now and do that. So I'm just going to do that real quick. Go into here, and so if you'll see that line, dropping the mark. Oh, you know what? I'm on the wrong timeline. This is just the monitoring timeline. You also have this timeline here, so pull up this one. Actually, I have to start recording with this one. All right, so now I'm doing that. So now I'm going to drop a marker. There you go. So I can go back. I can do a walk test. I can go stand at the podium. I can drop a marker. I can go to the dressing room. I can drop a marker. And I can go back later and go, okay, I dropped 3 markers while I was doing my walk test. I know what was happening with this transmitter at that point in time, and I'm all by myself.
Yeah.
So, you
Just
know,
gotta
what I
remember-
would have done for that as a touring monitor guy 10
Yeah.
years ago, you know, when it was all guesswork, you know, just had to kind of walk around and hope that you talked in every area that the body pack might be used in.
Yeah.
So I just jumped off topic there for a second.
That was cool.
Anyway, those are things that, to my knowledge, no other manufacturer has ever done. Once again, to my knowledge, with transmitters there.
Yeah.
Giving
Yeah,
you,
that's
giving
super
you
cool.
guys some extra tools to run with in the world. Yes. Okay. So go back to my presentation. So that's channel quality metric. We also have something called transmitter authentication now, which means you can authenticate up to 8 Accent Digital transmitters per receiver channel. And even if another Accent Digital transmitter turns on that same frequency, if it's not authenticated, a couple things will happen. It'll either block it from joining the channel, or it'll warn you that an unauthenticated transmitter is coming on and let it pass, or it'll just let it pass. Concept behind this is several things. Let's say you're in a big theater production, and you know, you're sharing body packs with receiver channels, or what if you're a touring band and you've got, you know, the guitar player's got 5 guitars and you only want 1 receiver channel, but you got 5 body packs. You authenticate guitar player A's body packs for his channel, guitar player B's for his channel. So even for some reason if frequencies overlap, it won't take charge of that channel unless it's authenticated. So that's that. Frequency diversity is something that we can do on ULX Digital body packs, and we can do them on Accent Digital 81 body packs, and then we can do them with Accent Analog and, of course, our Accent Digital ADX transmitters too. What this is, for example, with ULX Digital or 81 body packs, you can take 2 body packs, you put them in frequency diversity mode. The output from those 2 body packs, it takes the best signal for its audio output and puts it across both the outputs on those channels. So basically what that means is you can give someone redundant body packs and take a single output off of your receiver and take it to your channel, and the receiver itself will determine the best signal and use that to feed the audio. So even if you get interference on one body pack, you've still got the strong audio signal coming from the other body pack. And that's called...
Have you done this with your ULXD?
Never.
Well, for your football field, very common practice to double pack the refs, and we have a Y splitter. We actually have a little switch that I think is even in the case maybe. No, but it's in a great case for the referee that takes the one mic and then goes out to the 2 separate body packs. So if one drops, it automatically switches to the other.
Wow.
Yeah, that's called frequency diversity. So we can do that with ULX Digital 1 body packs, 81 body packs. We can do it with Accent Analog, and now we can do it with the ADX body packs. And we have a dual frequency ADX handheld I'll talk about in a second that transmits on 2 frequencies that does the same thing too. Of course, that takes up 2 receiver channels. But once again, for people of importance, mission critical wireless, you're just adding to the resilience of it. Latency is 2 milliseconds through the receiver, so really, really good. ULX Digital is 2.9. We've got something called Dante Listen Mode. So this does have a headphone output on the front panel of it. You might have noticed if you push that knob in, you've got an option called Dante Listen Mode, and you can actually pick off any Dante channel on the network. And it'll show you all the Dante devices on the network and grab them. As well, because of that, you can take multiple Axient digital receivers that are on the same network, and you can set up one to be a master Q station where the headphones stay plugged into it at all times, and the rest are slaves essentially to that master station. So whenever you hold down the channel button on any of those receivers, it solos the channel via Dante to that common headphone jack. So if you want to pick off the audio just from the receiver prior to your board or anywhere else it's going to go, all you have to do is queue up whichever channel you want, and you can leave your headphones plugged in that same place all the time. So for an A2 or a monitor engineer, someone like that'd be very advantageous to be able to troubleshoot any problems that way. Network control can be done from Wireless Workbench. We have the Shure Channels Plus app for Apple iOS, iPad, and iPhone, and then the Spectrum Manager, of course, can manage all this as well. There's the dual channel receiver, exact same thing as a quadversity channel receiver, except it only has 2 channels. And as a quad receiver, it doesn't do quadversity, and it's only 2 channels, and it's half the price. We talked a little bit about the AD and AD2 transmitters. These are your single frequency transmitters. Once again, this is the UHF-R replacement. These are shipping right now. They'll run on AA batteries just like ULX Digital, but you can also put in the SB900 rechargeable battery, which is the same as we use with ULX Digital, QLX Digital, PSM 1000, 900, and 300. So kind of form factor there. You can see the transmit powers are 2 milliwatts, 10 milliwatts, and 35 milliwatts. At 10 milliwatts with the rechargeable battery, it'll go about 9 hours. It's about 8 hours with the alkalines. And just like ULX Digital and those other products, if you are using the rechargeable battery, you can look at the receiver, you can look at the transmitter, you can see this from Shure Channels or Wireless Workbench, you can actually see in hours and minutes how long is left on the battery. Have y'all done that before? Do you have any of the rechargeable batteries?
No, we don't have the
So
rechargeables.
I go back to Wireless Workbench. Go in here. See over here in the top?
Yeah.
7 minutes and 4 seconds, or sorry, 7 hours, 4 minutes left on there. So kind of nice to be able to look at that battery information that way. But that's AD1 and AD2. Those are shipping now. That's what I would call our single frequency. Think of that like digital UHF-R. And then we have the ADX1 and ADX2 transmitters. These will only work with proprietary lithium-ion battery that comes with them. Comes with 2. Has special chargers for those. The body pack battery is different than the handheld battery, just like an Axient analog. It requires a little bit more power for these transmitters since they have to maintain that constant connection to the show link because they're constantly pinging each other. So it's just a little bit different power requirements, which is why that is in there. But essentially, other than that, they have a little bit longer runtime. They have the tone generator, and obviously these are the ones that can switch frequencies if you have a show link access point in Spectrum Manager. We also have the ADX2 frequency diversity handheld, and this can transmit 2 frequencies at the same time, so you get your redundancy. It does take up 2 receiver channels, but if one takes a hit in the process of while it's switching to a new frequency, the other one keeps on carrying through. So a single frequency ADX transmitter that changes frequencies, it's going to change frequencies in probably 30 to 80 milliseconds, somewhere in that period of time. So you could potentially get a little dropout, in someone talking, or if someone was singing, you might have a little dropout. The good thing with those is once it's changed frequencies, the likelihood of having another interference is not going to happen. So you're not going to continue to get dropout after dropout after dropout. But with a frequency diversity ADX, because one is still passing audio while the other one is taking a hit and switching, you don't hear anything at all. It's just completely seamless. It could be a held guitar note. It could be someone singing through, and you don't hear any dropout whatsoever. Pretty remarkable. The other thing you can actually do with this, so the FCC says you can't have a higher transmit power than 40 milliwatts, but using something called coherent coupling, we can do a high power mode using both transmitters on this and actually turn it into 63 milliwatts. May not sound like a lot, but think about this. A 10 milliwatt digital transmitter is the same as a 50 milliwatt analog transmitter. Wow. So take that up to 63 milliwatts digital, and you've got like a 250 milliwatt analog blaster equivalent. Now, you might take some of your other mics off the air, But for that mission critical mic, the cannot fail outdoor application, I mean, think about it. You can have frequency switching, you can have the 63 milliwatts, you can have the quadversity mode. There's a lot of things happening here to make sure that microphone signal does not get lost. So just another option there. I'm guessing, I haven't done this yet because we haven't got one of these. The ADX transmitters will be shipping in 2018. They're not shipping yet. Is that coherent coupling mode might take your battery down a little bit faster. You know, with Axient analog, when you go in the high power mode, it drops your battery life in about half. And it goes from about 8 to 4 hours. But you know, once again, you're basically welding with RF at that point. Yeah. And then this is the micro body pack, and this is something that theater has really wanted for a long time, and so we have this. It is an ADX transmitter, so it will change frequencies. It's not very big. It's about that big. You'll notice it has rounded edges. It has an internal antenna. What you're seeing on the right there is actually the LEMO connector. So it's an internal antenna. So unlike most body packs, which radiate very well away from the body, what happens when you take a body pack transmitter and put it next to a body? Yeah, you have some signal attenuation. So what this does, it actually has a self-calibrating internal receiving antenna. And so it's designed to radiate better off the body, and it will regulate its strength and transmit based on what it's determining it needs to, so that it can be equivalent in free space as up against the body. Pretty cool technology, but it's designed to be worn next to a body. Also, because of the rounded edges and the LEMO connector, it's got an IPX4 rating, which means that you can stand in a shower with this thing for 30 minutes and pass this rating test, and it'll keep on going. So for theater production where people sweat a lot and stuff like that, this is very resistant. There's also a sleeve that we're going to sell for this one that'll make it IPX7, I think, or something like that. And they've told us that means to pass that measurement, you have to be able to submerge it in water for like 15 minutes up to a meter deep or something. So 30 minutes, it's something like that. You know, so it could be even used as like a baptismal mic. But once again, for high-end production in Broadway and theater where they're wearing tons of costumes and they're just sweating and they're outside doing something at a football game, NFL, your stadium out here, that sleeve's going to keep it even more protected there. And so that'll be coming out later in 2018 as well as the ADX transmitters. And that's a size comparison there. So what you're looking at is the UHFR micro body pack on the right and the Axient Digital micro body pack, and then that's an Axient Digital ADX1 body pack, which is about the same size as this. So you can see that micro pack is just going to be, you know, compared to this, that gives you an idea of how big it is. It would fit in the palm of my hand. So,
I actually saw it at NAB.
Yep, they've been showing them. Yeah, NAB and Infocom, all the trade shows we've had it there. It's a pretty cool looking piece. Yeah.
And remarkable what it does in the way it radiates.
Yeah. These are some of our charging options. Basically, we have a rack mount charger. You can put the different batteries in. We have trays that just lay the batteries into them, and then we have sit-in or stand-in chargers. I believe we've got one sitting over there, you know, where you can just drop your transmitter in. When you drop a transmitter in one of those cradles like that, it does stop it from transmitting while it's charging. And lithium-ion smart battery technology, it stops charging when it's full, so you can leave it in there all the time. And we see that a lot in university classrooms and other stuff, or in churches where people just want that microphone right there by the stage or the performance area of the classroom, so someone just grab it and it automatically comes on when it pull it out, and they can just start using it, and when they're done, they just put it back in there. So
battery technology, if you don't fully use, you know, let's say you use a quarter of it and then you recharge it, is that damaging the body? I mean the battery?
It's not. No, it's
lithium ion, there's no memory effect whatsoever. So if you go down 30% and then come back up 10 and then go down 60% and come back up 40, that's not even one cycle count until you've taken it all the way down and all the way back up. Wow. So Shure did a cost analysis when ULXD first came out, single channel, that the amount of money that you save and not replacing, because you guys replace AA batteries every day, right?
Well, we recharge,
or rechargeable. So they said that over the lifetime of the product, not only will it pay for the AA's that you're using, but it pays for that channel. sell that transmitter and receiver. Now this is over 5 to 7 years,
Yeah.
but there's nothing else in the room that is paying for itself.
That's pretty
That's
amazing.
pretty
Yeah.
huge.
Yeah.
We have ULXD and Axion analog batteries that we've had for 5, 6, 7 years, and they're still at 84% battery life.
That's a long time.
Yeah. So lots of different charging options. This is the new ShoreLink access point. It's actually a diversity access point. This is required when you're using the ADX transmitters. You can control up to 16 transmitters simultaneously with this. So if you need to go higher than that, it requires multiple access points. Also, you can add multiple access points to the network to extend your coverage area. So you could have one in the room and one in the green room, for example. So you always have control over that transmitter that way. And we do have a high power mode for that as well. And then the other piece that you have to have, which is not in the slideshow, is the Spectrum Manager, which is that bottom piece over there. And that is a networkable receiver. It's scanner, actually. It's got 8 scanners in it. It's just constantly scanning UHF area. And so it creates the backup frequencies and monitors those. So if a transmitter detects interference, and it's an ADX transmitter and it can change frequencies, it's not hopping blindly to a frequency. It's hopping to a frequency that the Spectrum Manager's been monitoring for 2 hours, 3 hours, 8 hours, however long you've had it running and up and on, and knows that it has a history of being a good signal or a clean area to go to. And so that's what actually issues the frequency to the receiver and to the ShoreLink access point, which sends the message back to the transmitter to change to 582 megahertz. Now, whatever it is, you know.
So the manager, is that a one-to-one or?
It can control a whole system.
Okay.
And it works with all of our networkable receivers. So I could scan with that. I could be networked to your ULX Digital and my Accident Digital. It would find channels and monitor backup frequencies for everything. However, only an ADX transmitter or an Axion analog transmitter has the ability to jump, but you can put backup frequencies in there that you can monitor through Wireless Workbench software to know if they're clean for your other products as well, you know.
And you said that's you have to have that like,
For the
because
ADX,
it's distributing the actual.
that's correct. Yeah.
For the ADX to change channels, but for your example, you could have one Spectrum Manager and either move it to different buildings, to the stadium, whatever, and then it will, for a performance, it will calculate and then can deploy via the network compatible frequencies to all of the units that it's plugged into at that time.
Yeah.
The benefit of the ADX, when you bring in the ShoreLink access point, is then it can change those transmitters, or you have control of them. You can change the gain of the transmitter. You can mute the transmitter. You're not changing the output of the receiver. You're actually, you know, for the
I
guy
get it.
that says check
Yeah.
check
Yeah.
1 2 and he gets on stage and he's blistering the front end of your microphone. You
So-
can turn it down.
But that's only ADX. So AD, that's not applicable.
Right. So to take advantage of the interference detection, avoidance, switching technology with the ADX transmitters, you have to add a ShoreLink access point per every 16 transmitters and a Spectrum Manager, but just one for the whole network.
It's the system.
And you could even run one Spectrum Manager in multiple rooms by running
If they were
antenna. Yes, by running antenna into those rooms, and that would, like, if you had an adjacent
I get it.
auditorium, pair of antenna in that one and pair of antenna in that, all going to the same. You could even do it without that, but you'd want that other pair of antenna coming into your system, at least for the Spectrum Manager, so it knows where to go and it, you know, doesn't jump into the other room or something. But
That's the brain for the show.
it's the brain. Yeah. Any questions?
Latency from transmitter to receiver is 2 milliseconds. Is that impacted at all by the distance between the transmitters?
It's not. No.
Yeah, we're talking about uncalculable numbers of the actual connection.
Yeah. There is a penalty. I didn't mention this, but both ULX Digital and Axion Digital offer AES 256-bit encryption that can be turned on, which probably wouldn't apply to most of you. However, for corporate clientele or someone in that kind of thing, where there could be
NSA.
NSA or, you know, a bank,
Somebody
yep,
sitting in the parking lot recording the show.
banking institutions, whoever, right? You can turn on the encryption. It adds about 0.9 milliseconds to the system. Still below 3.
That's a very interesting kind of point, and sure, it might exist out there. The stealing of
Broadway
RF.
absolutely wants it encrypted because they don't want illegal bootleg.
Does that show up though when somebody can grab? Let's just say it's not encrypted, but somebody has another receiver. They power it up. Will that show up in your manager?
Now, if I went outside,
Stealth.
yeah, if I went outside and I had another Axient digital receiver and
crazy.
I could find your frequency, I could tune it in and I could probably grab that signal.
The manager has a headphone jack, so we may or may not have listened to other manufacturers at a trade show.
Yeah.
But, I mean, obviously with digital technology, it'd be much more difficult just to kind of pull up and listen to stuff. Of course, like you mentioned, the NSA. I mean, who knows what those guys have? Who knows what the Russians who rigged the election have? I mean, you know what I'm saying. We just don't know what's up there in the world.
The encryption though is
256-bit encryption. Yeah, it's AES standard, which is the same standard the United States government and military uses for generating a key. And it regenerates a key every time you do an IR sync with the transmitter. So if you ever just want to, if you think you're being followed by the Russians, just resync your transmitter every so often, and it'll clear out that key without even changing the frequency. Yeah.